Hey there, universe nerds! Imagine looking into the night sky and finding something so bright it outshines entire galaxies. That's not science fiction, that's a quasar. Quasars are the brightest objects in the universe, powered not by stars, but by supermassive black holes feeding on matter. They're cosmic lighthouses, blazing across billions of light years. And today, we're diving deep into what they are, how they form, and why they matter. Quasars were first discovered in the 1960s as strange radio sources with no clear explanation. When astronomers finally matched them with faint star-like objects, they realized the truth. These weren't stars at all. They were galaxies with incredibly bright cores. The name quasar comes from quasi-stellar radio source. But what we know now is that quasars are the blazing hearts of distant galaxies, powered by hungry black holes millions or billions times the mass of the Sun. Here's how it works. At the center of a quasar sits a supermassive black hole surrounded by an accretion disk of gas and dust. As matter spirals in, it heats up to millions of degrees, releasing enormous amounts of energy as light, X-rays, and radio waves. The process is incredibly efficient, much more than nuclear fusion in stars. That's why a quasar can shine brighter than its entire galaxy, even though the source is smaller than our solar system. Some quasars also launch powerful jets of plasma, blasting particles at nearly the speed of light across millions of light years. These jets can extend far beyond the host galaxy, shaping its surroundings and influencing how galaxies evolve. In fact, quasars may help regulate star formation, blowing away gas and preventing galaxies from growing unchecked. They're not just bright, they're architects of the universe. The most mind-blowing part is quasars are ancient. Because they're so bright, we can see them across incredible distances. The most distant quasars we've observed are more than 13 billion light-years away, meaning we're seeing them as they were less than 1 billion years after the Big Bang. They're windows into the early universe, showing us how the first galaxies and black holes formed. But quasars don't last forever. They're a phase in a galaxy's life when its central black hole is actively feeding. Once the gas and dust run out, the quasar dims, leaving behind a quiet galaxy with a massive black hole at its center. Our own Milky Way probably had a quasar phase billions of years ago. Today, Sagittarius A is relatively calm, but in the past, it may have blazed like a quasar, visible across the cosmos. Studying quasars has revolutionized astronomy. They've been used to map the large-scale structure of the universe, probe intergalactic gas, and test the limits of physics under extreme conditions. They're cosmic laboratories, teaching us about gravity, light, and matter in ways nothing else can. Every time we observe a quasar, we're learning about both the black hole inside and the universe around it. Quasars also carry a poetic truth. They remind us that even in destruction, there's beauty. A black hole devouring matter sounds terrifying, but the light it creates is among the most stunning in the cosmos. The brightest objects in the universe are born from the darkest forces. It's a perfect cosmic paradox, one that captures the imagination like nothing else. So, what are quasars really? They're not stars, not galaxies, but blazing hearts of galaxies in their most active, dramatic phase. They shine brighter than 1 trillion suns, visible across the universe, telling us the story of cosmic beginnings. Next time you look up at the night sky, remember, somewhere out there, quasars are still burning. their light racing towards us across billions of years, carrying the history of the universe itself.